This is 8.1. We're going to be solving simple trig equations. I will warn you now, this chapter is a little bit more difficult. You need to make sure you're staying with the videos and staying with the work and making sure you're asking questions. Not only that, make sure you're paying attention to these videos. I do a lot of explaining in these videos about why things work the way they work. If you're just trying to memorize everything, you're really going to struggle. So in the starting problem, this is a simple trig equation. And on the surface level, it's not really that difficult to solve, because to solve a trig function like this, or trig equation, we do just use the inverse trig function. So the inverse sine of 0.254, that will give us what our initial theta is going to be. So our initial theta here is going to be 0.257. And all I did was put that into a calculator, so we have 0.257. Now, again, this seems really easy on the surface, but the problem is that we are limited on our inverse trig functions on how many values we can get. So what I want to do is I want to go back real quick and talk about two different things. The first thing is I want you to think about the unit circle. So if we draw the unit circle here, we have a theta of 0.257. Well, what you want to think about is where 0.257 is kind of irrelevant, except that it's in the first quadrant somewhere. So if we say that this is in the first quadrant, what you should also be thinking about is that means our reference angle is 0.257. What you want to ask yourself is, there other reference angles on your unit circle where we're also at 0.257 and a positive value? So remember our little thing where we said all students take calculus. That means that sine is positive in the top right quadrant and it's positive in the top left quadrant. So what we have to deal with here is we're dealing with an angle that is going to show up in more than one quadrant. So there's got to be more than one answer. So what I also want you to think about is think about what an actual sine curve looks like. Now, we did this briefly in the last chapter, but you know, it's a cyclical graph that looks like this. So it cycles and it does keep going. But if you look at what this problem's asking, it's giving us the interval. Well, a sine graph looks like this. It starts all the way here at negative 2 pi and it goes to positive 2 pi. What I want you to think about is how many times during that entire graph will our graph be equal to, or will our y value be equal to 0.254? Well, I'm going to approximate it here because we know the top point is 1. So I would say like here, and then here, and then here, and then here. So all of those would be approximately 0.254. So we actually should be getting 4 values. But right now we are only starting with 1 value. So what do? If our first value right here is 0.257, what I then need to figure out is, what is my reference angle here going to be? So that way, the reference angle needs to be 0.257. But what will the actual angle value be? In other words, what's it going to take for me to get there? Well, real simple. What we're going to do is we're going to just take 180, or actually, I'm sorry, we're in radians. So we're going to take pi minus our reference angle, which is 0.257. And that's going to give us what another one of our angles will be. And you realize, again, sine is positive in the top right quadrant and the top left quadrant, so this is the other reference angle we're looking for. So we have pi minus 0.257 equals 2.885. So that is our second theta that works. Now, real simple, these are the two values we would get if we started at 0 and went all the way to 2 pi. The easy part about this is, if we wanted to go from 0 to negative 2 pi, we would just go in the reverse direction. So really all we have to do to get our other two values is do 0.257, and all we want to do is minus an entire 2 pi so we can get a negative. So we minus 2 pi, and then we would take our other value, 2.885, and we would minus 2 pi off that. Remember, anytime you add or subtract 2 pi, you're just going around a full circle to get into this exact same spot. So if you think about the unit circle, if we go from 0 to 2 pi, that's a counterclockwise turn. And if we go from 0 to negative 2 pi, that's a counterclockwise turn. So these two would be in the exact same spot. We just have to minus 2 pi to figure out what those negative values are. So the other two values are negative 6.026 and negative 3.398. So you can see that we have four values here now. We have this, and then we have these two. Those would be the four values, the four angles that would give us 0.254. So you can probably see why this gets a little bit tricky. Okay, next thing before I have you do it on your own is what happens if no bounds are given to us? Well, actually, in my opinion, this makes it a whole lot easier because what we want to do is we would want to find our first initial values. So if I want to know what our answer is, our theta is actually going to be equal to 0.257, and as I said, it'll just be plus 2 times pi and then times n, because all we have to do is it's any multiple of 2 pi. And then our other answer would just be 2.885 plus 2 pi n again, because again, that's any multiple of 2 pi. That would be what your theta is if no bounds are given, because our initial values are 0.257 and 2.885, and then any 2 pi after each one of those. So that's where your values would be. All right, so you have one to do on your own here, so try that. It's very, very similar. The only thing that's different is you're using degrees now. So just keep in mind that you're using degrees. Put your calculator in degree mode before you solve that initial equation, and then everything else should be exactly the same. So let's see how you do. This could have been a little bit tricky for you, but at least what I want you to be able to do is come up with your first value, which would have been 139.20 degrees. So that's your first theta. If you notice, 139.20 would be in the second quadrant here. So what we would need to do is, so we have our first one, we know that's 139.20, but how do we figure out our other one? First of all, cosine is negative. Therefore, our other value is going to have to be down in the third quadrant here. So what we would do then is we would figure out what our reference angle is here, which is 180 minus 130.20, which equals 40.8. So if our reference angle here is 40.8, then the reference angle for our other answer has to be exactly the same thing. It still has to be 40.8. So to figure out what the total number of degrees to get to that 40.8 is, we would have to do 180 plus 40.8 to get 220.8. So the second answer is 220.8. To get your third and fourth answer, because we're from negative 360, we would just minus 360 off of each of those two answers to get negative 220.8 and negative 139.8. And that's it. Okay? The second one, where there's no bounds, we would just take the first two values that we got and we would just add 360n for each of those, and that would tell us every single time that cosine of theta would be equal to negative 0.757. Again, if you're having trouble understanding the concept here, what you need to do is you have to go back to the concept up here. You have to go back to the graph of a cosine and sine function and realize that because these things go on forever, it's just basically a wave. It's a wave that goes on, that all of these values are going to be hit infinite number of times, and they're hit after a certain amount of time. Every cycle we go through on a sine curve is 360 degrees or 2 pi. So if I know that it's going to be 0.254 right here, then I know that exactly 2 pi later, when the cycle starts again, it's going to be 0.254 again. And that's where kind of the understanding of this comes about. Okay, so moving on to something different. This stuff is a little bit easier. We're going to talk about inclination, and this is going to be a real quick explanation. Inclination is, let's pretend that I were to just draw a line randomly on your paper here. What the inclination will always be is inclination just means the angle measure between the x-axis, the positive x-axis, to the line. So if we were to take out a protractor and actually measure that angle, let's just call it 155 degrees, that's what inclination is. It's from the x-axis directly to that line and whatever angle that creates. So over here, if I were to draw another line, looks like this, same idea, we would go from the x-axis to the line, so something like this might be more like 35 degrees instead. Okay, so inclination is from the x-axis to the line, the degrees in between those. Okay, so that's important for us to understand for the next thing that we're going to talk about. Keep in mind, inclination has to be between 0 and 180 degrees. Okay, so let's move on. How are we going to do that here? Well, we're going to use inclination to actually find the slope of a line. So if we were given an angle here that is 30 degrees, hopefully you're familiar with our 30-degree angles because we can create a special right triangle here where, and I'm going to draw it a little bit bigger over here so you can see it. A 30-degree angle will have a side of 1, and then we have a side of square root of 3, and we have a side of 2. So the thing is if I wanted to find the slope of this line right here, what I could do is I could say I know that this point right here is 0, 0. And I know this point over here, based on the two values that we have here, is an x value of square root of 3 and a y value of 1. So if I found the slope, m would be equal to y minus y, so 1 minus 0 on the top, divided by x minus x, square root of 3 minus 0 on the bottom. Well, that would give us 1 over the square root of 3. And then, of course, we would have to rationalize the denominator. So we would end up with the square root of 3 over 3. But the thing I want you to notice is, notice this value right here. It is the exact same thing as the tangent of this triangle. Tangent would be opposite over adjacent, 1 over square root of 3. So because it's equal to the tangent, we can now use this formula below. That's where this formula comes from. The slope of any line will be equal to the tangent of the inclination of that line. So up here, the inclination was 30 degrees. So we could have said that the slope would just be equal to the tangent of 30 degrees, which is, of course, equal to 1 over the square root of 3, which ends up being the square root of 3 over 3. So really, really easy to do. It's a really easy formula to know. It's just slope will equal the tangent of whatever the inclination is. Okay, so now let's look at this example and then we're going to be done. It says find the inclination of the line to the nearest degree. Well, up here then, what we're looking for is we're looking for the inclination, but what we have to do is figure out what the slope of this line is. So how do we figure out the slope? We use algebra. We're going to isolate our y. So that's going to be 3y equals negative x plus 5. I'm minusing x to both sides. And then we divide both sides by 3. So we end up with y equals negative 1/3 x plus 5. So the slope of our line is negative 1/3. We already know that. So what we're going to do is use this equation to actually solve. So that means we're going to have the tangent of alpha equals negative 1/3, because that's what slope is. Slope is equal to negative 1/3. So now we're going to solve. Inverse tangent of negative 1/3 will give us our alpha. So our alpha is equal to, when we use the calculator, negative 18.435. So again, I wish this was always simple, but it's not, because we can't have an inclination of negative 18. So what we would need to do is we would need to look on our unit circle, and we would need to figure out where would we get another line. So negative 18.435 for our angle would be down here, but again, that line would be continuing on through to the other side. So what we would do to figure out what the actual inclination is we would just add 180 degrees to this. So if we added 180 degrees, that would give us our true inclination. Or we could do 180 minus that. It doesn't really matter. But either way, our inclination ends up being 161.565 degrees. Okay, so we're going to obviously work on all this stuff more in class. I will see you then. Bring questions then.